Missions to Icy Worlds, Human Voyages to the Outer Solar System. Written by Rod Pyle, read by Rod Pyle. We are down and safe. Welcome to Enceladus. These words may one day, perhaps late in the 21st century, be sent back to Earth from the outer solar system. That message, traveling at the speed of light, could take as much as 90 minutes to reach home across that vast interplanetary distance, but they would represent a crowning triumph in human spaceflight. Of course, we haven't even sent people to Mars yet, and moving beyond the asteroid belt is a far longer journey. But some forward-thinking people have been working on such problems, and they feel that once we've figured out how people can endure the multi-month journey to the red planet, going beyond will primarily be a problem of scaling and technological progress. All that said, there are many roadblocks to using current technologies to reach the outer solar system with people aboard, including long flight times, the effects of microgravity on the human body, and that eternal space bugaboo, radiation. None of these are kind to human beings, but between research on mediating the effects of extended spaceflight on our bodies, possibly to include a centrifugal artificial gravity module such as the one envisioned in 2001, A Space Odyssey, and various pharmaceutical interventions, it may be possible within a few decades. Shorter transit times will help too. New work in nuclear propulsion systems, engines that use well-understood nuclear fission technology to heat stored gas to provide extremely powerful propulsion, could cut travel times by a significant fraction. Regarding radiation, new materials, including a very promising compound called hydrogel, could provide an edge. Hydrogel is a very light substance that absorbs water easily and, if used to surround crew modules, could be flooded with water. The gel holds the water in place around the module, and that water is an excellent radiation blocker. An added advantage is that the water can slowly be drained for drinking and providing additional oxygen for the crew. It's the first win-win in radiation abatement technology in some time. While all this may seem quite far off, a recent research paper from NASA's Jet Propulsion Laboratory gives hope. Entitled Avoiding the Great Filter, a Projected Timeline for Human Expansion Off-World, the paper models spaceflight and associated technology trends from across the 60-odd years of the space age. As the authors put it, quote, "The goal of this analysis is to provide a projected time frame for humanity to become a multi-world species through off-world colonization, and in doing so all but guarantees the long-term survival of the human race from natural and human-caused calamities that could befall life on Earth." It's lofty phrasing, but laudable goals. The targets for such extended voyages of exploration could include the icy moons of the gas giants Jupiter and Saturn, ultimately including Enceladus, Europa, and others. Specific to Jupiter, the study identified Callisto as the most promising target, as it is sufficiently removed from Jupiter's intense radiation field to be relatively safe for human habitation. When looking at Saturn, Titan was deemed the most promising location for siting a human base, with Enceladus a close second. Speaking of Titan, while drilling through the ice crust of a moon like Enceladus is an attractive prospect for those seeking life in the presumed warm ocean below, Titan has some unique and promising characteristics. While severely cold, as all the outer solar system bodies are, Titan has a thick, soupy atmosphere that provides some radiation protection and is dense enough that transportation by propeller-driven aircraft might be possible. The explorers could likely move about in heated, cold weather gear and oxygen masks. No traditional pressure suits needed. The range of postulated dates for these expeditions range from 2040 to 2080. The paper goes further and suggests that crewed missions beyond the solar system to places like Alpha Centauri, specifically the exoplanet Proxima b, could be possible during the 23rd century, while intergalactic journeys might occur in the 24th. It's heady stuff and rarely written about in scientific journals in a human spaceflight context. A core driver for this research is the notion that there are various threats to life on Earth that should not be ignored. These include eruptions of supervolcanoes, such as the one lurking beneath Yellowstone National Park, that could befoul the atmosphere, making life on the surface nearly impossible, asteroid impacts, and even radiation emitted by a nearby supernova, though we would have to resettle in another solar system to avoid that, if even possible there. The bottom line, as the authors put it, is, quote, "An aggressive and sustained space exploration program, which includes colonization, is thus seen as critical to the long-term survival of the human race." Of course, this all begs the question of what we will do once we arrive in these distant places. There is plenty of scientific investigation to be carried out, but much of this can be performed, albeit more slowly, by robotic probes. The real imperative, as pointed out by the authors, is to set up permanent human habitation there, to make humanity a truly multiplanetary and ultimately interstellar species. This spread into the solar system and beyond will assure our continued survival as a species and also allow us to tap the vast resources of space, including volatiles like water ice from which breathable air and rocket fuel can be made, and the metals found in asteroids and on the moons and planetary surfaces beyond Earth. This reach into the solar system will not be easy, nor will it be inexpensive, and it is likely to be beyond the reach of a single government. Even an enormous, expensive project like the Apollo program pales in comparison. Success will certainly involve a combination of public entities such as NASA, the European Space Agency, China, India, Japan, and others. Interwoven with this will be commercial operators working both under public-private partnerships and for their own profit. International cooperation would be key and could represent a true flowering of global harmony not seen in at least the 80 years since the culmination of World War II. This is another lofty goal, but certainly one worthy of our aspirations. At the end of the day, this discussion is one of global survival. As the great Russian scientist Konstantin Tsiolkovsky once said, quote, "The Earth is the cradle of humanity, but mankind cannot stay in the cradle forever." Inspired by him and others, we've taken the earliest steps, going first into Earth orbit with small crews, then onward to the Moon multiple times. We then returned to Earth orbit for extended durations to learn more about long-term exposure to space and to perfect the life support systems necessary to stay there. It's time to move beyond. As the study concludes, quote, "By creating at least one and preferably multiple self-sustaining and genetically viable off-world colonies, humanity can best assure its long-term survival from both natural and human-caused calamities that threaten life on Earth." We couldn't agree more. This article is the featured cover story in the spring 2025 edition of Ad Astra magazine, available by subscription or to all full members of the National Space Society. For more information, go to nss.org. The paper referenced in this article is Avoiding the Great Filter, a projected time frame for human expansion off-world by Jonathan Jiang of Caltech, Philip Rosen, and Christian Fahey of JPL.